All right, so today we are going to start talking about rates, ratios, and unit rates. And the I can statement for the day is I can determine rates and unit rates when given words, tables, or graphs. So we're going to work toward that today. Last year you should have done some with ratios and unit rates and rates. So part of this may be a review, part of it may be new, and we'll just pick up and make sure that we understand what's going on. As we start this unit, we'll be leading into proportions. Proportionality is huge in the 7th grade, so as we start talking about the rates and ratios and unit rates and proportions, it's very important that if you start to get lost or you don't understand something, that you let me know pretty quickly. So to begin with, a ratio is a comparison of two quantities using division. And ratios can be written 3 different ways. They can be written where they look like a fraction, 3 to 4. They can be written with the words 3 to 4, or they can be written with a colon in between, 3 to 4. And this might be like if we're talking about stars to circles. There are 3 stars for every 4 circles. So that ratio is 3 to 4. 3 stars to 4 circles. A rate is a ratio of 2 quantities with different units. So we've got 60 miles in 2 hours. So you might be able to drive in your car and go 60 miles in 2 hours. And that's going to be a rate. And then a rate that has a denominator of 1 is called a unit rate. So where we had 60 miles in 2 hours in this problem, that is not a unit rate because it's got the 2 as the denominator. A unit rate is going to have a denominator of 1. But these 2 rates are equal. So if you can go 60 miles in 2 hours, that means you can go 30 miles every hour or in 1 hour. So the unit rate is going to have a denominator of 1. So then we've got an example. So there are 45 males and 65 females in a subway car. The subway travels 2 5/10 miles in 5 minutes. So it says in A, find the ratio of males to females. So whatever comes first in our sentence is going to come first in our ratio. So we want the number of males first. So we look up here and we've got 45 males and 60 females. So when we're looking at the ratio, we've got 45 males, and I'm going to put it as a fraction, and 60 females. So the ratio would be 45 to 60. When we're looking for ratios, you also need to go ahead and simplify the ratio. So 45 over 60 can be simplified. We can divide both of those by 15. And 45 divided by 15 is 3. And 60 divided by 15 is 4. So the ratio of males to females is 3 to 4, and we could write it as a fraction. We could write it with the words 3 to 4, or we could write it with a colon in between 3 to 4. Those 3 things are the same thing written 3 different ways. The speed of the subway car, so we're going 2.5 miles. So we're going to write that 2.5 miles goes on the top. In 5 minutes. And when we're looking at speed, we want to figure out not how fast we're going in 5 minutes, but we want the unit rate. So we want to know how fast we can go in 1 minute. To get from 5 minutes to 1 minute, we're going to divide by 5, because 5 divided by 5 gives us 1. Whatever we do on the denominator, we have to also do on the numerator. And then we've got 2.5 miles, or 2.5 miles, divided by 5. We put the decimal point above where it is in our division box. And 5 does not go into 2. But 5 does go into 25 5 times. And then 5 times 5 is 25. And then subtract and get 0. So you can go 0.5, or a half of a mile, in 1 minute. So that's the speed of the subway car. Then we've got finding the unit rate from a table. So in this particular table, it says that the table shows the distance that the International Space Station travels while orbiting the Earth. And we want to find the speed in miles per second. Miles per second, which means the per is going to be like your fraction bar. So we always put the miles on top if they are listed first, and then we'll have our fraction bar and the seconds on the bottom. So when we look at the table, we've got the time across the top, 3 seconds, 6 seconds, 9 seconds, 12 seconds. And then the distance in miles is 14 4/10 miles, 28 8/10 miles, 43 2/10 miles, and 57 6/10 miles. So when we want miles per second, this means miles per 1 second. So I don't want to know how far it can go in 3 seconds, or 6, or 9, or 12. I want to know how far it can go in 1 second. So you can do that any number of different ways. The easiest way is just go to one of the sections of your chart, and we're looking at the top and the bottom. So if miles goes on top, we would put 14.4, or 14 4/10 miles in 3 seconds. And I want to know how far we can go in just 1 second. So I'm changing the denominator. I want to know 1 second. To get from the 3 seconds to the 1 second, I have to divide by 3, because 3 divided by 3 will give me that 1 second. And then whatever I do to my denominator, I also have to do to the numerator. So then I've got 14.4 divided by 3. I'm going to do that over here. So I've got 14.4. I'm going to divide that by 3. I need to make sure that I put my decimal here. And then 3 doesn't go into 1. 3 goes into 14 4 times. 4 times 3 is 12. 14 minus 12 is 2. And then I'm going to bring my 4 down. And 3 goes into 24 8 times. And 8 times 3 is 24. 24 minus 24 is 0. So I can go 4.8 miles in 1 second. Now, we could have gone to anywhere in the chart, and I just kind of want to show you this just so that you know. I could have gone to the 28 8/10 and the 6, and if I do that, and I would have divided that out, 28.8 divided by 6, and then I put my decimal here. 6 doesn't go into 2, 6 goes into 28 4 times. 4 times 6 is 24. 28 minus 24 is 4. Bring down my 8. 6 goes into 48 8 times. And I still would get that 4.8 miles per second. The same thing is true if I would divide 43 and 2/10 by 9. I would get that 4.8. And 57.6 divided by 12 would also give me 4.8 miles per second. So that's my speed. And as long as you go to one of these columns and divide your miles by the seconds, you will get 4.8 because it's traveling at a constant speed. So 4.8 miles per second. Last, we're looking at finding a rate from a line graph. So we've got this line graph and it's showing the distance that sound travels through water. Find the speed of sound in kilometers per second. And so we've got kilometers per second. If you look, the time in seconds is on the bottom in this, and then the distance in kilometers comes up the side. So when you're looking at this point right here on the graph, the 2 is the seconds and the 3 is the kilometers. So the 2 represents the seconds and the 3 represents the kilometers. So if I'm looking at kilometers per second, I would put the 3 kilometers on top and then the 2 seconds on the bottom because I want kilometers per second, which means kilometers has to be on top. And then I want to find the unit rate, so I don't want to know how far it can go in 2 seconds. I want to know how far it can go in 1 second. So to get from 2 to 1, I divide 2 by 2 to get 1. And whatever I do to the denominator, I also have to do to the numerator. And 3 divided by 2 is 1.5 or 1.5 kilometers per second. Just like we could go to any point in our table and get the same unit rate, we can do that with the other point that they're showing us on the graph here, which is the 4.46. So the 4 is the seconds and the 6 is the kilometers. So if we want kilometers per second, it would be 6 kilometers in 4 seconds. And to get the unit rate of 1 second, I would have to divide by 4 because 4 divided by 4 gives me the 1 second. And then I would do 6 divided by 4. And if you don't know what that is, 6 divided by 4. We've got 4 goes into 6 one time. 1 times 4 is 4. When I subtract, I have 2. Since I've got a remainder, I add a decimal and a 0 because that's still 6. It's just 6.0. I bring down that 0, and then 4 goes into 20 5 times, and 5 times 4 is 20, and I've got that 1.5 or 1.5 kilometers per second when I use that point as well.